Hey Rams, I want you guys to give yourselves a big pat on the back. It's been a big week for everybody with the Keystones going on and all the other school activities and home activities. You guys are awesome, and we are almost done with this 5th section in Chapter 11. So today we're going to still be talking about parallelograms and triangles. However, the difference is going to be we're not so much going to be focusing on learning new formulas. We're going to be recalling a lot of information that you guys have learned this past year, mostly SOHCAHTOA, remember that? And how to find the measure of angles inside these polygons. Here we go. Let's check out this example. Find the apothem, perimeter, and area of a regular nonagon. Nonagon is a 9-sided polygon with radius 5 feet to the nearest tenth. Okay, so what we're going to have to find now is our apothem, little a, our perimeter, and the area of the nonagon. Again, the nonagon here means that it's 9-sided. Things to recall. Let's remember the formula to find the measure of each interior angle. Remember, each angle is number of sides minus 2 times 180 divided by the number of sides. We're going to be using this quite a bit in this half section of section 11. Another thing I need us all to recall was the wonderful SOHCAHTOA. Our trig functions, the sine, the cosine, and tangent of given angles. Okay, let's get back to this problem here. We have a nonagon. Now I'm not going to draw the 9-sided figure. I'm going to draw one of the angles. So let's imagine this is the center of our nonagon, and I'm going to be drawing in my radius. Remember, it's not just a circle that has a radius, and I'm given that the radius is 5, the segment joining the center to the vertex. And it would be great if I could find the apothem and then the perimeter, which means I'm going to have to find this side here. I'll multiply it by 2 to get the whole side, and then I'll multiply it by 9 to get the perimeter of the nonagon. And I'm going to call this one a little short a for the apothem. Okay, first steps. Let me find the measure of this angle here, so I can divide it in half to find the measure of this angle inside my triangle. Okay, we're going to be using the formula that I posted up earlier. Number of sides is 9 minus 2 times 180 over 9 will give me the measure of that full angle in there. So I'll have 7 times 180 divided by 9, and my answer is 140 degrees. Now the whole thing here is 140 degrees, and I only want half of it. So with my black pen, I'm going to write 70 degrees is this internal angle here. Now we're going to use our trig functions, sine, cosine, or tangent to find a. So if I'm standing at the 70, I have my opposite, and I have my hypotenuse, which means now I'm going to use sine. So the sine of 70 equals opposite, which is a, over hypotenuse, which is 5. Now I have to solve for 5. Multiply each side, solve for a. Multiply each side by 5, and a will equal, my apothem will be 5 times whatever the sine of 70 is. Plug that into your calculator, and I get a equals 4.7, and it'll be feet. So a, my apothem, is 4.7, and I'll write it in here, 4.7 feet. And I use that again by using the trig function, but before that I used the formula to find each angle. I divided that by 2 to get 70 degrees for that interior angle. Now the next question is the perimeter. Wouldn't it be great now if I could solve for x down here, and I'll multiply it by 2 to get the full side. Okay, we're going to be using another trig function. So if I'm standing at 70, again, right over here, x is my adjacent, and 5 is my hypotenuse. So adjacent and hypotenuse now will be cosine. So cosine of 70 equals adjacent, x, over hypotenuse, 5. Multiply both sides by 5. and I'm going to have x equals 5 times the quantity of whatever cosine times 70 is. And if you plug that in, you should get 1.7. So x here is 1.7. Now remember, it's half. It's half of my side. So I'm going to multiply it by 2 to get my full side. 1.7 times 2. And then that answer is going to be 3.4. 3.4, you guys, is the length of one side of my nonagon. So to find the perimeter, I'm going to take that one side and multiply it by the number of sides, which is 9. And my answer to that is 30.6. So my perimeter is 30.6 feet. Good job, you guys. Thanks for hanging in there with me. The area, lastly, remember, of the polygon is 1/2 apothem times perimeter. Let's just plug it in. 1/2, 4.7 times 30.6. Put all that in your calculator and you will get 71.9 feet squared. That was a lot of work, Rams. Way to go. Let's move on to the next example. Example 2. Find the apothem, radius, and area of a regular pentagon. A pentagon is a 5-sided figure with perimeter 60 centimeters to the nearest tenth. So apothem, radius, and area. Those are the 3 things we're looking for of our pentagon. Again, I'm not going to draw the whole thing. I'll just draw one of the sides. That's the center. I'll have my radius drawn in, and I'll have my apothem drawn in. And here, they just told me that the perimeter is 60. Now, with this information here, if I go 60 divided by 5, which was the number of sides, I'll get 12. So I know each side is 12. Now, to help me with this problem here, I'm not going to use all of 12. I'm going to make that 6, and of course this other side here was 6. The full length of one side is 12, and I'm just dividing it in half because that's what my apothem is doing from the center to the opposite side. It's cutting that opposite side in half. And so the question now is, what's my apothem? I've got to figure out what this angle is over here first, though. Again, each angle equals the number of sides minus 2 times 180 over the number of sides. Let's simplify that, and I get the number of sides is 5 minus 2 times 180 divided by 5, and keep working that out, and we get 108 degrees. Now the whole thing's 108, and because a radius bisects that whole angle, I'm going to divide it by 2, and I will get 54 degrees, which is what's represented in here, 54 degrees. Let's find my apothem and then my radius. Okay, using SOHCAHTOA, I'm standing at 54. The apothem is my opposite, the radius is my hypotenuse, and the 6 is the adjacent. So I need to use the 6 somewhere because that's my given information. So to find A, I'm going to be using opposite, that's opposite of 54, over adjacent, and so that's tangent. So let's take the tangent of 54 equals opposite, which is A, over my adjacent, which is 6. And so now I'm going to be solving for A. Multiply 6 by both sides, and I have A equals 6 times the quantity of tangent of 54, and then that answer becomes 8.3. So my apothem, ladies and gentlemen, is 8.3. So I've figured out this one, 8.3. And now to find the radius, you have 6 down here, you have 8.3 here. We could use Pythagorean theorem to find it, but since we're already on a roll with the sine, cosine, and tangent options, let's keep going with that one. So let's say I'm still standing at 54. This time I'm going to take the cosine of 54, and cosine again is adjacent, 6, divided by hypotenuse, which is r. Let's solve for r. Multiply both sides by r. And now I'm going to divide everything by cosine of 54 to isolate r. So now I have 6 over cosine of 54. I just isolated my r. And you plug that all in your calculator and you'll get r equals 10.2. Okay, so the radius is 10.2. Hang in there with me, you guys. We're almost there. Now the area formula, again, is 1/2 apothem times perimeter. I have my apothem. It's 8.3. So let's start plugging things in, you guys. We're almost done. 1/2 apothem is 8.3 times my perimeter. Now the perimeter, we first need to find the full side. And looking back at our figure, the full side here is 12. And it is a pentagon, so I'm going to do 5 times 12. 12 is the length of each side, and there's 5 sides in there. And now work all of it out for me, and you will get 49.8 centimeters squared for the area. Bam, we did it. Moving on. Okay, Rams, find the area, perimeter, and radius of a regular octagon. And now an octagon is an 8-sided figure with apothem 4 inches to the nearest tenth. So we're looking for area, perimeter, and radius. And yes, an octagon has a radius. It's not just circles that have them. Okay, so I'm not going to draw the whole octagon. I'm just going to draw one of their angles here like I usually do. And I'll find the center, draw one apothem, and draw one radius. Okay, I'm given the apothem is 4 inches. Okay, it would be great for me to find a side, and let's get started on that. First things first, let's find this angle here. And remember, each angle equals the number of sides minus 2 times 180 divided by the number of sides. The number of sides in the octagon is 8, so 8 minus 2 times 180 divided by 8. And we simplify that and we get 135 degrees is what that whole interior angle is. Okay, divided by 2, and I'll be writing it now in black. It's 67.5 is the angle inside of our triangle there that we just created with half of the base of the octagon, the apothem, and the radius. Okay, bust out those trig functions, people. SOHCAHTOA. We're standing at the 67.5, and I want to find my base. I'm going to call this x. So 4 is opposite, x is adjacent, so we're going to use tangent. Tangent of 67.5 equals 4 over x. And now let's go ahead and solve for x. Multiply x by both sides. And then I'm going to divide both sides by tangent of 67.5 to isolate x. And I have x equals 4 over tangent of 67.5. Put that into your calculator and you will get 1.7. And 1.7, I'll mark it here in blue, is half of the base of my nonagon. So if that's 1.7 and this side also is 1.7, the entire base then will be 3.4. Okay, now I'm going to use that information here to find the perimeter. I'll do 3.4 times 8 because there's 8 sides. And to get that then, I will get 27.2. So my perimeter is 27.2 inches. The next thing I need to find is the radius. The radius, I'll mark it here in blue, is r. Let's use SOHCAHTOA again, since we're on a roll with the trig. You could also use the Pythagorean theorem and do 4 squared plus 3.4 squared, and then solve for r squared. But again, we're on a roll with the trig, so let's go ahead and do that. I'm standing at 67. I'm going to use my 4, which is the opposite, and then r, which is hypotenuse, and that's sine. So sine of 67.5 equals opposite 4 over hypotenuse r. Multiply both sides by r, and then I'll divide both sides by sine of 67.5. And r then becomes isolated, and I have r equals 4 over the value of sine of 67.5. And finish that up, and I have r equals 4.3. So my radius is 4.3 inches. Last thing they're asking me for is the apothem. I'm sorry, the area. The area is 1/2 apothem times perimeter. And so the apothem we got is 4, and the perimeter is 27.2. Work all that out in your calculator, folks, and you will get 54.4 inches squared. Awesome. Folks, here's your homework assignment. I'm going to be handing out the review worksheet in class, and we'll also post it on my e-board today. Get ready for that quiz tomorrow. It's going to be great. So proud of you. Bye, guys.